Yeah, I can't stay in one place at one time. I'm very curious, so I jump around. Okay, so the title of my talk today is Harnessing the Collective Wisdom and Power of Smart Data, Smart People, and Smart Machines in Smart Cities, a research agenda. And what I'm presenting today, I'm calling a little bit provocative. I'm going to essentially argue here that our vision, or actually Michael Batty's and other people's vision for the future smart city may not in fact be realized. And in fact, we could be dealing with a growing information market failure related to big data, growing inequalities, inequities, information asymmetries, information gaps, information monopolies, and it's only going to get worse with the rise of not only smart big data, but also smart machines and smart people. And so I want to talk a little bit about that and kind of highlight what's going on in the socio-technical landscape and where we're seeing these kinds of issues arise and why they might continue into the future. And then I would like to talk a little bit about some potential solutions using an emerging framework or a paradigm called human data interaction as a way of thinking about how to address these issues. And at the end of the day, basically I'm arguing, as other people have said, I've seen a couple, I just rolled off the train, so unfortunately I've only seen 2 presentations, both were very good, but kind of highlights some of the things that were said in these prior presentations. Okay, so Mike Batty and others have this vision for the smart city of the future, and I assume this is what folks were talking about this morning. And people are talking about the city kind of becoming cognitive, becoming more and more like the human brain. And actually the term cognitive cities I found goes back to Novak in 1998. And he talked about a cognitive city as being capable of learning, remembering, and retrieving experiences through man-machine cooperation for promoting resilience, sustainability, and efficiency. Kind of what we're talking about now, okay, and many people are talking about. But what's interesting about Novak is when he came up with the idea of cognitive city, that was in a completely different socio-technical landscape than what we're dealing with right now. 1998, that was the beginning of the internet, or beginning of the World Wide Web, Web 1.0. We hadn't even began Web 2.0, interactive web. Okay, so, or smartphones, mobile phones, none of that was around. Okay, but what we're seeing here is what I would like to call a next generation cognitive city emerging, at least the concept of it emerging. Now I'm going to argue that we may not be able to fully realize this for a number of reasons. And so what we're dealing with now is a different socio-technological technical landscape here, which actually very closely tracks the World Wide Web. Okay, so down here we have Web 1.0. This is where Novak was. Okay, then we saw Web 2.0, interactive web, social media, increasing social connectivity. Then we get the semantic web, connecting information. Okay. All sorts of content mining and those kinds of things, knowledge management, artificial intelligence. And so here we see increasing information connectivity. And now where we're at up here is Web 4.0. Actually, we're moving quickly into Web 5.0. And Web 5.0, by the way, is basically the World Wide Web. We will be able to sense our emotions and feelings. And we are actually moving into that territory. But up here, Web 4.0, we're talking about the World Wide Web as a global brain. Okay, very similar to the way that we're talking about cities right now. Okay, so we see a lot of terms being thrown around. I've heard the neuro-computational city. I've heard the city brain. I've heard cognitive cities. Okay, all sorts, the sentient city. Okay, all sorts of things that reference the human brain. And what we have in this landscape here, I would argue, are 3 components: smart people, smart machines, and smart data. Okay, oops. Of course, smart data, we're talking about big data. smart people, but that also includes institutions. And smart machines, here's where things get a little bit complex and very interesting. What we are talking about are a variety of machines that are AI-driven. Okay, robotics, autonomous vehicles, sidewalk robots, drones, okay, other kinds of AI that's operating in the background. Some of it's invisible, we can't see it. Many different varieties, I'll talk a little bit about that in a second. Many different varieties of AI, deep learning, okay? And what this is doing is it's creating a new sort of interaction, a new sort of complex network in cities or smart cities. One that has interaction going on between smart machines, smart humans, and smart data. Okay, and that creates a lot of problems. And what I'm seeing here is that increasingly humans are falling outside the loop. Okay, and rather than becoming the human-centric city, we're becoming a machine-centric city. Okay, so here is a schematic showing this kind of network concept I have. So we have machines and we have humans, and each of these are exchanging data or information. And what we have here are a number of problems that I can go as far as saying these have all the makings or trappings of an information market failure. That needs to be fleshed out a little bit. But we have information gaps and disparities, information asymmetries, power imbalances, lack of inclusiveness. And all of this has implications for resilience, sustainability, and livability, and potentially create suboptimal outcomes. Okay, so let's quickly look at the changing socio-technical landscape and how these machines and humans, humans and machines, machines and machines, and humans are interacting in new ways, and how this is creating information asymmetries and power imbalances, et cetera. Okay, so we have the idea here of the social machine, and the idea behind the social machine is that you have machines and humans working together, but basically humans are the ones doing the creative work. They're essentially in charge at the end of the day, and machines are doing the administrative work. So here we get into citizen sensing, crowdsourcing, all those kinds of things. What we're seeing, though, actually, is the rise of machines, smart machines, in these kinds of systems, in social machines. So you can think about social media, bots, which are automated software agents. Okay, there's an interesting study that came out that showed that, 30% or more of all tweets are made by bots. Okay, the memory of the city, we're seeing the rise of blockchain, and blockchain is a shared, distributed, or decentralized digital ledger which uses cryptographic algorithms to verify the creation and transfer of digitally represented assets or information over a peer-to-peer network. Okay, it's a record of all human transactions. And this is where we're headed in terms of keeping track of things, in terms of recording data, in terms of recording all these transactions. It's immutable and it's permanent. But what's going on here? We have machines. Machines, anytime a transaction is uploaded to blockchain, it goes out to millions of computers, and it's validated via AI and other kinds of algorithms. Okay, Internet of Things here. People have already alluded to Internet of Things, of course, is tracking everything from the contents of our refrigerator to the real-time performance of critical infrastructure. What we're seeing here is that IoT, we're actually seeing the rise of crowdfunding. Not sure if you're aware of this, where in fact you can have an idea for a device to be plugged into the Internet of Things, and you can get funding to support that. Okay, so we have humans and then we have machines. Machines are the sensors. We have AI running behind the scenes, analyzing all the data that's coming up. IoT is becoming an increasingly fragmented space. So this is one way to look at it. So we have things like we have self-contained, infrastructured, private versus public here. So we have the connected cooking pot right here. And then we have connected smart homes. So these are all private. So these are individuals, citizens providing that data. They own it, they know it, and the city may not know it. On the other hand, we have up here public IoT. Okay, so we're seeing this kind of increasing fragmentation and information asymmetries related to this. Another issue here has to do with the dataverse and who's actually producing this data. Okay, so the old days, and of course we still have this going on, we have the public sector, we have the government doing surveys and those kinds of things, collecting the data. It's open, it's visible. Privacy is less of an issue. If it's an issue, the government will deal with it. Census does a very good job of that. But now we have these robots and smart machines, autonomous vehicles being one example, which are collecting tremendous amounts of big data. The statistics are staggering when it comes to autonomous vehicles, how much data is being collected. But who owns the robots? Who owns that data? Who decides how that data is used? It's Uber, it's Google, it's Waymo, okay, the big companies. And those companies, as somebody already mentioned, may not have the public interest in mind. Okay, big data is a world traveler. Okay, it goes through a complicated logistics chain where at each stop it gets repackaged and repurposed and reprocessed. Okay, there are a whole slew of information asymmetries in that pipeline, okay, which creates problems with metadata, okay, and other kinds of things. Okay, and those who have actually produced the data have more information than those who are using the data down at the far ends of the pipeline. Okay, an interesting thing here is that these smart machines are increasingly driving the dynamics of all sorts of systems here. So in social media, bots are actually swaying opinion. They actually had an influence in the last presidential election in the United States. Of course, financial markets here. We have high-frequency traders who are causing big swings in the market. Okay, and then we have autonomous vehicles. There has been a lot of work being done doing simulations, looking at how autonomous vehicles actually change the dynamics and systems properties of traffic. Okay, is this a good thing or a bad thing? Is it leading to suboptimal outcomes, information asymmetries? Is it stifling serendipity? Machines are irrational. One could argue machines, AI, have perfect information. Okay, what are the implications of that vis-a-vis humans who have less perfect information or imperfect information and may behave more irrationally? Okay, and as I mentioned, AI and these smart machines, there are many different varieties here. Okay, so we actually have asymmetries, information asymmetries between machines. Okay, so you can think of autonomous vehicles, for example. One company may be using a deep learning model that's better than the model that's being used by another company. Okay, cloud computing, autonomous agents. Somebody already mentioned this. Autonomous vehicles, for example, all of that big data that's being collected by those vehicles gets fed up into the cloud, into cloud robotics. We have machines talking to each other, the vehicles talking to each other. They're doing computations, exchanging information. There's no human in that loop. It goes back down to the vehicles to affect the performance. Okay, so the question is, and this is just kind of a highlight, we could talk more about this, but just to give you a flavor of this, but how can we race with the machines rather than against them, or worse yet, behind them? Okay, so I think human data interaction is a useful paradigm to use to help frame solutions and strategies. It follows from human-computer interaction, HCI, and HCI is just simply interaction with computers as artifacts. HDI is more complex and essentially places the human at the center of the flows of data, providing mechanisms for citizens to interact with these systems and data explicitly. It's about collaboration, human input, okay, humans in the loop. Okay, and according to HDI, and I've already kind of alluded to this, one of the issues here is that human here in the loop, the citizen or the public manager, the city planner, has basically, there are two areas where information is opaque. One has to do with the raw data that's being produced. Okay, oftentimes we don't even know what's being collected about us. I just found out what Facebook has been collecting on me. I wasn't real happy. We don't know also about the analytics here. Okay, this gets into algorithmic transparency and whatnot. And according to HDI, we have these three things here that we lack. And again, I think this is a useful way of thinking of solutions and strategies to deal with these kinds of information asymmetries and increasing power imbalances and whatnot. Okay, number one, we lack legibility. That is, we lack the means to inspect and reflect on our data to understand its collection and processing. Number two, we lack agency, the means to manage our data and access to it, enabling us to effectively intervene in these systems as we see fit. And we lack negotiability, which means that we lack the means to navigate data's social aspects in collaboration with others and policies. Okay, so what we need to think about here, and this pertains to both humans and machines here, when we design these kinds of interventions to deal with the kinds of issues I'm raising here, is we need to ensure that we have legibility, awareness of the data that's being collected, but not only that, we need to have awareness of the implications of the data collection and use. The data representation needs to be intuitive. We need to have agency, as mentioned, ability to opt in or opt out, ability for informed consent, but also revocation. If we see something up there that's collected on us and it's wrong, we should have the ability to retract it. Negotiability, ability to reevaluate their decisions as contexts change, for example, people, data, or machines crossing jurisdictional boundaries, and ability to provide contextual integrity. Context has come up a couple of times here today. Machines are not very good at understanding context yet. Humans are very, very important in dealing with that. Okay, so agenda for research and action. So just a couple of things to think about here. Number one, we need to have a better understanding of the dataverse, particularly in relation to these three things: legibility, agency, and negotiability. What data is being collected? Is it public or private? Okay, where do we have legibility? Where do we have agency? Where do we have negotiability? And where do we not? How do solutions and strategies vary depending on type of big data in terms of these three things? Okay, dashboard design. Okay, we might want to think a little bit outside the box here. So again, the whole idea behind HDI is that there are humans in the loop. So when we think about dashboards, it shouldn't be a top-down kind of platform which just presents the information, which has analytics built in, churning numbers. We need to have human input. Humans need to, number one, understand what's in that dashboard, and they need to have the ability to intervene, to help create that data, to analyze it, to correct it, and so on. We need to think about different kinds of computational techniques that can make the data representation intuitive. Granular computing is an emerging computing paradigm which allows us to look at data at varying levels of abstraction. Okay, and this here, hybrid analytic and forecasting. So this is really hot right now. So there's a huge project going on right now. I can't remember if it's NSF funded, where basically they're using the crowd to do very, very long-term forecasting of geopolitical conditions and circumstances. I'm talking 100 years out into the future, okay? And that's combined with AI and machines, okay? It's a collaborative kind of thing, very hot. So we might think of embedding something like this within a dashboard for an urban area, for a city, okay? And complex adaptive systems modeling. I would argue that in order to better understand how machines, smart humans, and data are all interacting, and whether or not we're dealing with suboptimal outcomes, how we can effectively intervene in these systems to create better outcomes, complex adaptive systems modeling, I think, is the way to go. Okay? And lastly, as mentioned at the beginning of the talk, and as highlighted, at the end of the day, human collaboration is what is critical. Humans are needed in the loop. We need public-private partnerships, cooperation, collaboration. We also need multi, inter, and transdisciplinary collaboration, and I would like to throw this out to Peter and Karima. Perhaps we think of an ABC where we bring together urban and regional planners and scientists with artists and computer scientists and see what happens. Thank you.
Thank you, Laurie. That was a very enlightening thing because it gives us some tool maybe to prevent the big divide, if we can call it that way.
It's a different kind of divide.
Yeah, it's a different kind.
Yeah.
Any questions?
Thank you. It was really interesting. When you talk about smart people, I guess you are defending the stupidity, the right to be stupid. Because, like, is smartness the thing, what is threatening us people? I feel that it's not making the best solution, but making a human solution. And that could be not the smartest one, but the most. So isn't this like a defense for human stupidity?
Okay, I don't know if I'll go that far. But essentially what I'm getting at here is that smart people are people that have access to the data and information they need, and access defined broadly, as I talked about in my talk here.
Yeah, but don't access, and it's also the right to make different decisions than the machine makes.
Right, exactly. Yep. Yeah, because the machine is not perfect. It's far from perfect.
Well, you spoke about deep learning. Do you know application in for smart cities or urban planning or city management regarding deep learning?
Are there potential applications of deep learning?
Real applications.
Oh, implications of deep learning?
Yeah.
As in negative implications? Or
Applications?
oh, applications. So if you come to the World Congress in Goa, Manfred has organized a session on deep neural learning for urban and regional science, so we might see some interesting applications there. But deep learning is already being used all over the place in cities. It's working behind the scenes. That's IBM Watson. We can't see it, but it's there. Yeah.
This is not only a question to you, but more also to the rest of the audience about what about the opportunities for criminals or the big data, etc. And also on an entrepreneurial yacht, if you really want to make money, you can also be on that part of the scale as an entrepreneur. I'm just wondering, is that something you consider or look at in your research?
Yeah, I think that I didn't have time to talk about that, but certainly that's an element here is use of big data and use of algorithms for criminal activity. Okay, we could go into a number.
Not as a police force, but more as a criminal yourself.
Right, that's
The business model for criminals.
the business model for that might be Cambridge Analytica.
I've never come across any technology that hasn't been used by criminals. So, I mean, this will happen the same here. That's at least.
And I didn't have time to highlight this either, but we're seeing the rise of nefarious kinds of machines too, and something called adversarial deep neural learning, which is not a good thing. We don't want to see those kinds of developments, and I don't know where that's going to be headed.
Okay, thank you very much for a very enlightening presentation.